Hi, everyone. My name's Josh. I'm from Formlabs Inc., and I'm presenting a session called Anywhere Manufacturing, Overcoming Barriers to Production with Additive Manufacturing. We're just going to talk a little bit about Formlabs as a company, where we've been, where we're going, and then talk a little bit about where we view the future of additive manufacturing in a world where supply chains have been disrupted, and we're looking into a lot of new ways to bring manufacturing home. So again, just going through the agenda, it's real simple, 3 bullets. I'm going to cover who we are at Formlabs, what we're doing, so where we see additive manufacturing changing the world, how we see it impacting industry, and sort of a vision for where our new technology is bringing us, and then segue that into the technology we've developed to do it. We've got some really exciting new solutions that have just come out that we're just starting to see deployed into a lot of different customer facilities. Want to go over that, talk a little bit about how those work, what's involved there, and the potential that we see. So starting with Formlabs and talking a little bit about our history, we were actually born out of a Kickstarter, 2.95 million. It was a record-breaking Kickstarter. It was, in the sort of era, 2014, Kickstarter was becoming really a big thing, and hardware Kickstarters were a new concept that were exciting to people. And that was really with the promise of bringing stereolithography, SLA, a type of additive manufacturing that was inaccessible for a long time, to a much broader audience at a much more affordable price point. That really resonated with people. And so you can see we started as a pretty small team with a fairly narrow scope in 2014 and have grown really quickly since then. Today, we're over 600 employees globally. We're located all over the world in a variety of offices. We have global resellers where we're shipping to every corner of the earth. And you can see we've really expanded our product offering from 5 materials to more than 30. And all of our materials development, in addition to the hardware and software, is all in-house. So some numbers on this slide. We really pride ourselves on even in a short amount of time, having been around, having seen a lot of different prints, different parts, different use cases, because we've got customers who've printed more than 85 million parts. We've shipped more than 75,000 printers, which makes us, by volume, a real leader in the 3D printing space. And the company just keeps growing. I'm excited to say we just finished a funding round very recently, our Series E, and we're now valued at over 2 billion. It was a big deal in 2018, which was around when I started, when we were first valued at $1 billion and became a unicorn. Now we're at 2 billion. We're still going strong. We just keep growing headcount, growing spaces. We're all over the world, in Germany, Japan, China, Singapore, Hungary, and North Carolina, but I'm based out of our Boston office, which is our headquarters. So it's a really exciting time for us, and people are really beginning to, not beginning to, they're really seeing the value that an accessible, available 3D printer can add to their business now that it's easier than ever to integrate it. I just want to give a quick sort of vision into the history of the company and take a sidebar here to talk about what do I mean by SLA becoming more available, accessible. This was a technology that came about in the 80s and has been around since then, but only with the Form 1 and 1 Plus, which were pretty tightly joined in the early 2010s, did it become something that could be done on the desktop. And so we've really made our name making professional, highly usable, extremely accessible machines that deliver professional quality, similar to what you'd get in an industrial machine. Something that, in the past would involve a lot of dedicated floor space, a lot of dedicated facility planning, and really highly trained operators. And you can see here we've sort of progressed and built on this theme, starting with the Form 1 and 1 Plus, moving to the Form 2, which was really the product that got a lot of adoption, saw a lot of circulation, and got our name out there. And now we're on the 3 and 3L series, and the 3B and 3BL are just our medical and dental models of the same printer. So we've expanded, we've gone to a larger format, we've gone to newer technology. I could bore you with the details, but this really is an evolving space in 3D printing, and it's great to see how excited people have been about it. So here's a basic overview of our catalog now, in terms of what we produce, what kind of hardware we offer. So 3 and 3B, same size, but they differ in terms of the applications they're used for. 3L is another thing we launched recently, large format machine. Wash and cure are accessories for those for post-processing. And then Fuse 1 and Fuse Sift, which I'm going to talk about more in depth later in the presentation, are our first foray into SLS, so that's selective laser sintering, which is a technology that uses powdered plastics. We focus on nylons, at least for now, and uses a laser to sinter those into solid parts. If you've gotten 3D printed parts for something functional or something end use outsourced before through either a partner location or a vendor of yours or a manufacturer that offers on-demand 3D printing, SLS is likely a technology that you've explored or maybe seen parts from, and it's getting a lot of adoption in the industry as a rugged end-use type of manufacturing. This is our mission statement, and I want to bring this in here just because I think it's a good way to frame what Formlabs is all about, but also as we talk more about where we see the industry going, our vision for the future. This idea that anyone can make anything, and that's just increasing accessibility to the technology, and not just increasing accessibility to the technology by offering really inexpensive things, but by offering really powerful things that don't require a lot of upfront investment in terms of your time and labor and specialized skills to be able to use like a professional user. You know, for a long time, I think especially in the early 2010s, you saw sort of a boom in media coverage of 3D printing. You saw people excited about, oh, everyone's going to have a 3D printer on their desk. It's just going to be like an inkjet printer or a laser printer. Everyone's going to have one at home. It's going to be really great. And it was sort of sparked by the fact that a lot of other companies' printers were coming out at such a low price point, but they weren't really competitive in the way that anyone could make anything with them. They were still catering very much towards a hobbyist consumer sort of mindset. We feel like we've really elevated desktop 3D printing to the point where it is a serious technology that can be scaled up and brought into production applications for true end-use parts. Just to sidetrack for a second and talk about me and who I am. I know I gave a brief intro at the start. I work on a sales engineering team in North America, and what the sales engineering team does is essentially work with customers, clients, partners of ours to assess and consult on installations of printers, basically look at their business, talk through applications with them, and determine the best fit in terms of product materials, but also process and the way to integrate it into their facility so that they're successful. We really, you know, as part of this mission, we've wanted people to get our products, become successful with them, and then scale and become true power users of 3D printing. So I work on that. I'm really fortunate to talk to a lot of people who are using these in real world applications, talk to people who really understand what they're doing and have a really diverse set of uses for 3D printing, and help them to install 3D printers in often really unlikely places I would never expect. So I feel like I learn a lot from that every day. Hopefully I can share some of that with you now. And that's sort of why I'm the one giving you this presentation, and I'm the one delivering it, is hopefully my insight is a little bit of help for you as you're thinking about 3D printing. So segueing out of Formlabs, the company, and our past and our mission, I want to talk a little bit about where additive manufacturing is going and the vision that we have for the value it can provide, especially in the world we're in now. And so this is the part where I give you the sales pitch, right? And I say 3D printing is a disruptive technology. We're going to change your business to the point where you won't recognize it anymore, right? That's probably the pitch you've heard from 3D printing companies, maybe from Formlabs in the past, saying, this is really disruptive. It's going to change the way we do things. Things are going to be changed forever. But as I was putting this presentation together, and as I was thinking about it, and as I'm talking to customers and people who want to work with us, I'm realizing more and more, and I think the world is realizing more and more that right now everyone's focus is on minimizing disruption, right? So I could tell you, oh, we're going to disrupt your supply chain, but your supply chain is probably already disrupted. Everyone's is. If you've tried to build a shed or buy a house, or if you see the latest news report and people are buying toilet paper or raw chicken or whatever it is, people are concerned about supply chain, gasoline, lumber, any of this. Everyone's had a supply chain issue in the last year. It seems like supply chain issues for certain things are going to keep going. And so a lot of the conversation right now is, how do we bring manufacturing home? How do we restore the American supply chain? For a lot of reasons, but just because businesses need to move without disruption. It's great to want to improve and change your processes when things are stable, but when there are external factors causing shortages or changes in the way that you have to do things, especially when certain locations are blocked off to you, 3D printing takes on a whole different significance. It becomes something that has a different level of importance in your business. And so, looking at these headlines, looking at all of this, I want to sort of present a different vision of what 3D printing can do for you. And I titled this "Anywhere Manufacturing," and that's because I think we have this mission statement, right? Anyone can make anything, but there's one missing component to that, and that's the location part. And so you might say, great, I understand, injection molding. I understand blow molding. I understand setting up a machine shop to do these parts in mass that I'm trying to produce. But it's all bound by location, right? The location of where you're handling your manufacturing and where you're sourcing components is often more important than the method. And that's for a number of reasons, but most of them are barriers to manufacturing, right? Cost of labor. You might locate based on the workforce you can get, the cost of labor in that country or in that state, cost of raw materials. There might be places where raw materials are more accessible than others. Access to raw materials is another big one, right? You might have the location with a perfect workforce and a factory set up ready to go, but if you can't ship things there, if you can't get them there, you're going to end up with issues. Shipping time transport ties right into that, but especially when, and I'm focusing a lot on production and making large volumes of parts, but this could be prototyping in your facility, right? This could be, I'm working on a design project. I need to turn around a new prototype every week so that I can stay on time, on budget. But my vendor is taking an abnormally long time, or my vendor's not taking a long time, but it's taking a long time to receive something from my vendor. So shipping and transport comes into it. Again, tied into lead time, right? Marries perfectly with that. I need something by this date to stay on schedule. I need to be doing things at this regular cadence, and vendors just can't keep up these days. So all of these are reasons I hear from people all the time as to why they want to talk to Formlabs, why they're interested in 3D printing, why they think it's something that's compelling, and especially, talking about all those things, why they want to bring it in-house. Right, insourcing versus outsourcing is always a hot topic in 3D printing. Maybe I can get it from another vendor, but maybe I'd get more control if I took it in-house. And control is really the name of the game here, right? If you can eliminate these barriers, you've got control of your supply chain, you've got control of your processes, you have control of the parts and supplies and components that you need to deliver an effective product. And the reason this picture is on here, this might just look like a generic picture of some plastic parts, is this is actually a component of the Fuse one, our product that came out most recently, and we're seeing a lot of acceptance of. There were certain components, normally we might injection mold this, or maybe not. We're a plastics company, but we produce these in one of our facilities, and it's we do manufacturing all over the world. We print a lot of these right here in the States in a facility where we just had some extra floor space, moved some fuses over there, and we started printing them out. And this was a really great agile way for us to remove one thing from the supply chain that we had to be concerned about finding a vendor to produce for us. We produce them ourselves, we produce them in-house, and we do it in a fairly small area. I'll show you some pictures of installations later, with relatively few operators, right? Labor cost is not a huge concern for us printing these because the printer does so much of it on its own. And so it's great when we're bringing new products to market, or when we're looking for the most effective way to produce something, to be able to look at a quote from a vendor or look at a lead time from a vendor and say, actually, I think it's more effective for us to just produce it ourselves. And we can very easily, very quickly, not even tool up, just get the equipment that we need to do it and go straight from a model to a part. So another picture, another couple of pictures from a facility. I think this underlines how little space you need to see an impact wherever you are. This is from Tessie Plastics, who are a great customer of ours, participated in our beta for Fuse. And this is a picture from from a user story we did with them. You can check it out on our website, just showing their first fuse setup. And you can see this is not a crazy amount of floor space. This is not a huge dedicated room for this thing. This is two 120-volt outlets on a shop floor that they already had. And they can produce all the stuff that they need to keep their line going. You see on the right, they produced those components for a machine that they use every day. They were machining those out of aluminum as they needed replacement or as they needed to swap them out prior to this. And by having a fuse on site, by having it in-house, ready to go when they need it, they could produce, without going through an external supplier, without going through a machine shop or anything like that. They could just produce parts as they needed them, which gives them a lot of flexibility, but it also gives them a lot of security that their manufacturing facility is not going to experience any downtime if something breaks, if they need a replacement part, any of that. Again, this goes back to that idea of control and controlling your supply chain, but also controlling your facility. You retake some of that control by having a really agile manufacturing tool like this. Again, a couple quotes here from a couple different users of ours. Left one talking about saving time and resources and just the speed that you can bring something to market, or the speed that you can get a part that's needed, that's necessary for you to keep going, if you have an additive solution like this. So, these are both companies that we worked with that obviously have a lot of different ways to get components, to get parts, but saw a lot of value in bringing it in-house and having a solution that mitigates a lot of those barriers to producing whatever they need, anywhere they need it. Everyone likes to talk about making things where they're going to be used, or even in other contexts, right? You want food to be grown where it's going to be eaten. There are a lot of ideas about producing things, going back from this decentralized model and producing things where they're going to be needed. And 3D printing is sort of the ultimate for this when we talk about plastics, metals, things that are more difficult to make complex parts with, because you can set up one of these installations, a little bit of labor, a little bit of time, a little bit of floor space, and just like that, you can produce a huge portion of the things that you need right where you need them. And so, I'm starting to dwell on the fuse one. I'm starting to talk about this technology, and I recognize a lot of you probably haven't seen the product, aren't familiar with it. Maybe you've never heard of SLS, Selective Laser Sintering. So I want to take a step back and talk a little bit about what the system is, what it looks like, what an installation is kind of consisting of. And you can see here a picture of a part sitting in a bed of powder. This powder is your raw feedstock for the material. So super easy to store, super easy to understand. We love to throw this line out at Formlabs. We're doing for SLS what we did for SLA. And I've heard it to the point where it sounds a little cheesy, but it's very true, which is why I include it in these presentations, is why I say it to clients and people we're working with. If you think back to earlier in the presentation when we were talking about SLA stereolithography and the evolution there, it used to be high performance at a high cost. And that high cost is machine cost, but it's also time, labor, expertise. It's all of the things. It's floor space. It's setting up your facility. It's building a process around it. We're taking that and we looked at that and we said, this is a great technology, but it has the same limitations that a lot of traditional manufacturing technologies do. We're very constrained by labor. We're very constrained by location. We're very constrained by having a facility that can support it in terms of the infrastructure of that place, in terms of the floor space, in terms of the head count, all of these sorts of things. Why don't we take that and build something that can deliver similar quality, similar throughput, all of the same performance that you've come to expect from the technology, but in an unobtrusive, non-disruptive package. And that's really what the fuse is. You see this line, industrial quality on the benchtop. It really is something you can sit on a benchtop, sit in the corner of your office or whatever space you've got, and still get parts out that would rival that of anything you get from one of your existing vendors. See on the left, a picture of some headphones that we printed the casing and straps to, or I don't know what you call that, headband to. It's a really high quality material, nylons in general, and our formulation of nylon 12, nylon 11. These are not like a lot of the materials that people have come to expect from 3D printing if they're only exposed to FDM, SLA, technologies like that have historically been more accessible. Nylon, you guys all know the name. It's an end use, really robust, high performance material, and being able to print it without compromise is a huge game changer in terms of integrating 3D printing. A few bullet points here. Efficiency. Again, this ties into just having something in house, but you can run these machines back to back to back to back, which ties into high throughput. We have people running these in manufacturing facilities. I mean, we're running them ourselves in production for end use components of one of our products, and we're not doing it to be cute or to be fun, as having that as a talking point, as a marketing point. We did that and stood up an installation of these printers because it was legitimately easier for us than going to injection mold it and integrating that into our supply chain. In the middle there, part quality, the parts that you're getting out of this are true end use parts. I can keep saying that over and over and over again, but I want to stress this because I think there's a perception of 3D printed parts as being weak, as being of low quality, as being generally unusable for real things. When we're talking to people interested in adopting Fuse, the interest is always, can I use this like I'm going to use the final product or as my final product? And the parts really do hold up to that. In terms of some selling points, some reasons people are excited about it, accessible price, known materials, production applications. And so I want to take a step back here and talk about the journey for a lot of people in getting this in-house. We'll talk to a lot of people and they'll say, okay, I know what nylon is. I understand how it works. I understand that it's going to be suitable for my application. But if I want to produce it in a traditional way, it's going to involve a high upfront cost. What's exciting about the Fuse is you can start with a fairly inexpensive upfront cost. A fraction of what it would cost to do it either with injection molding or with a traditional industrial SLS machine. You can get it in-house, and then you can begin producing with it. And you can see a chamber on the right. We can pack parts in here really, really densely, because unlike a lot of other 3D printing technologies, there's no support involved. You can just pack and use the entire usable volume of the chamber in the machine and just produce huge batches of parts. The nice thing about having a low upfront cost, a lower priced machine combined with affordable materials, is it makes it very easy to scale. And I'll show you again a couple pictures and examples of people who are scaling with us. But I've had a lot of customers who are getting into a new product. Maybe they're a startup, or maybe they're a larger company that wants to try something but is limited in the capital they can put up front to do it. Or maybe they're testing the market. Right? Maybe they know there's a market for hundreds of these or thousands of these, but not tens of thousands or hundreds of thousands, the kind of quantities where they would need injection molding, and they would have to commit to a minimum quantity and warehouse that inventory and warehouse those tools and everything at that point. The great thing about having a machine this size, this scale, and this cost is you can start with one, get your capacity out of it, and when your capacity or when your need exceeds the capacity you've got, scale up to another one, scale up to another one, scale up to another one. Got amazing free management software that lets you check the status of all of them, manage them all at once from a single terminal, and you can scale very easily. And that's what we're seeing with a lot of companies who are really getting into production with us, is they go, all right, I need a little capacity right now. I'll buy one. I'm going to use that to generate demand. And once my capacity outstrips it, I'll buy another one. And we're seeing people already scaling on an order of only a couple months between machine purchases. To really hammer this home, I'm not going to dwell on this too long, but here's an image of all the space that you need to set this up. You'll notice there are no callouts here for ventilation, for inert gas, which is often a requirement with SLS printers. For any hookup besides, what you do need is a 120 volt outlet, and each one needs a dedicated 20 amp circuit. So if you've got a wall plug, if you've got power that you know is good and you can trace it back to the breaker, obviously you can. That's it. That's what you need. You need enough space to sit these things. What is that? About 40 inches wide for one of them, about 30 inches wide for the other. So 6-7 feet on your shop floor. You can have your entire manufacturing solution against one wall. And we're going through a build out right now at our headquarters. I run a few fuses. I'm doing it in a converted conference room right now. It's under 200 square feet. We've got 3 fuses, 2 sifts in there. We could probably jam more in if we needed to. And we managed to set it up in a couple days, because it's so easy to move these things around, to set them up where you need. And once our construction's done, we'll move them back out, and I'll put them back where I need to. It's not like setting up a CNC or something where you're thinking about the entire ecosystem around it. This really fits where you need it. And again, talking about producing things where they're needed and barriers to that, you can think of that on a macro scale, right? Am I producing it in the right country? Am I producing it in the state? Am I producing it at one of my facilities as opposed to someone else's? But you can also think about it as sections of your facility, or facilities within a company. I hear from a lot of people, we would love to do SLS printing, but our mothership location 3 states away, they've got the 3D printing stuff because they've got the floor space for it. They've got the headcount, they've got the facility for it. So we just send things to our sister location or whatever it is. And they're coming to us, they're interested because they can take back a little control even within their company and set it up, because they've got a couple power outlets. They've got 7 feet on a wall that they can set these things up side by side. And so it's really exciting to them, even at sort of that narrower scale, not where they're bringing stuff home from China or Vietnam or something like that, just where they're bringing stuff to their facility from another one. So here are the pictures I promised you. And this is what a manufacturing facility looks like with Formlabs 3D printers. Doesn't look that impressive, right? Doesn't look that huge, but this is what a high volume facility can look like. And these are both setups that we've got and that we've been operating in Formlabs HQ, which is again Somerville, Mass, just outside of Boston. What you've got on the right is a room we stood up with 8 fuses and 2 sifts. And by doing this, we can produce literally thousands of parts every week. Right here, we have one operator who comes in, checks everything, uploads files, pulls things out, dusts the parts off and throws them in a bin. But these things run overnight without supervision. They'll run 7 days a week, back to back jobs. It's very easy for us to say, oh, we need additional capacity. We need to print more parts for fuse. We need to print more samples to send to prospective users. We need to print more of whatever we need. We'll use it for internal prototyping. We'll use it for product development. And just look at this farm and say, okay, we could produce, we could decide at lunch that we need to produce 1,000 of these this week. And by the end of the day, we've got it going. So that's a real game changer, even for us as a 3D printer company who's thinking about this all the time. Having fuses around has really changed the way we do things. On the left, 3L, I mentioned this machine earlier. Again, it's a large format machine. You can make dozens, hundreds of parts a week on it. And these are parts that sort of mimic injection molded quality, right? These are extremely smooth, precise, accurate parts ready to show to your marketing team or your customer. And again, doesn't take up much space. That's also 8 of these machines. And you can see we've got it on a couple shelving units in the side of a decidedly office type space, not really an industrial sort of facility. So, when people think about manufacturing installations, they tend to think big, they tend to think of what they're used to. And when they think 3D printers, I think they tend to think small. They tend to think, okay, we'll have one of those, we'll throw it on a desk. This sort of solution where you get the power out of a large manufacturing facility in the footprint of something much smaller is something we're really excited to be exploring with more and more users. Just to round it out with a couple of examples, and these are user stories that you can check out on our website. You can read more about it. You can learn a little bit about what some of our customers are doing. But a couple quotes here. One is for Bros, who are a leading European manufacturer of OEM auto parts. So they're a huge supplier to a lot of the large auto manufacturers. And this is from Christian, who highlighted really that the setup is very easy. If you have an enclosed room with air conditioning, you're basically set to go. It doesn't have a lot of space requirements, so that's very good. There's no real calibration needed. All you need to do is make sure that it stands level. You can plug it in, you can start the setup process and print on the delivery day. again, I know I've stressed this before. I know I've mentioned this, and at risk of repeating myself, it is just that easy to bring one of these things in and have manufacturing exactly when you need it. We get calls from people all the time. Hey, I have a project deadline. The project's in a month. How soon can I start producing parts? And we look at the calendar and we go, I don't know, 2 days, 3 days. How soon can your people be ready to take delivery? That's a paradigm shift, because there's no tooling involved. We're not quoting minimum quantities. We're not trying to figure out batch manufacturing. Once you've got the equipment, you're ready to go. The other one I want to highlight is from Print Parts, which is a great service bureau, great contract manufacturer in, I say unlikely locations. They're in Manhattan. How many people, would think, oh, I'm standing up a manufacturing facility. I want to do it in Manhattan. I need the floor space for a manufacturing facility. Let me buy some real estate in Manhattan. But these guys did it. And they did it because it's a great location for them. It's a great location for their customers. It makes a lot of sense to have some manufacturing, because there is still a lot of industry in New York. And what was really exciting to them is, they were running a lot of smaller format printers. They were having great success with that. Their customers were looking for SLS parts, these rugged end-use nylon parts to use in their products. And Fuse was the solution that would fit in the allotted floor space that they had in their facility without a whole lot of interruption. Again, you can see another picture here of just how little space it takes. People working behind it, set it up really in whatever kind of space you've got. But they could get this thing installed. They could get it set up, even in their facility in Manhattan, without compromising a lot of floor space. So just having something that gives you the most performance per square foot is always a concern when we're thinking about bringing something in-house, and being able to do that is, again, a game changer for a lot of companies who this would have been inaccessible to prior. So, wrapping up, going back to that mission statement, Formlabs is expanding access to digital fabrication so that anyone can make anything. That's been our mission statement for a while, and it's been something we've really stuck to and focused on and tried to make a reality. But and don't go telling Max, our CEO, that I'm here tweaking his mission statement, because this is not an official change. But I think anywhere is a component that we can start to add to this confidently when we're talking to people about their facilities, when we're talking to them about their sort of workflows, the barriers to their production, the barriers to them running a great business, no matter what's going on with supply chains, no matter what's happening anywhere in the globe. Making anything anywhere is really something that's going to propel us forward and our users forward, and make them ready to tackle any challenge as we continue going into this uncertain time for manufacturing. That's what I have for you. Thanks everyone for sitting through, for listening, for considering, and learning a little bit about 3D printing and where I and Formlabs see the industry going, and some of our experience with customers. Love to wrap up and take questions now, and see what you all think about the content here. Thanks.